So with product of sums, what we're really doing is tracking if we're not at any of the zero conditions. If we're not at any of the zero conditions, we must be at a one condition. So we're not at any of the zeros, we must be at a one. So I want to kind of approach explaining this problem using De Morgan's kind of argument, or I guess not De Morgan's argument, but we're going to apply it to get at our canonical form. So the first thing is let's find out where our zero conditions are at, right? This is a 0 and this is a 0. And how do we describe if we're at one of these rows? How do we describe if we're at one of these rows? Well, we take a hint from our sum of products form, which is we're at this row if we're at A not B, right? A not and B means that we're at this condition here, A not ANDed with B. Then our other row here is A ANDed with B not. So remember, product of sums is saying we're looking for if we're not at either of these conditions. Not at either of these conditions. So let me flip this real quick and say, what if I wanted to check if we are at either of these conditions? If we're at either of these conditions, all we'd have to do is OR them together. Are we here or there? Here or there. So if I want the opposite of that, saying if we're not at either of these, that means what I can really say is here nor there. Here nor there. So it's the nor function now. So that means we OR it and then not the output. That's what parentheses around it with a not means. We're ORing it, then notting the output. So this is a true way to represent this function. But we usually don't like having this not on the end here or at least the way our canonical form for product of sums is stated. We don't want this not on the end. We want it to look like a product of sums. And right here it kind of looks like a sum of products inverted. So what we're actually going to do is we're going to distribute this not, right? We're going to distribute this not or apply De Morgan's complement, right? So this is DC, right? De Morgan's complement. We're going to apply De Morgan's complement and see what we end up with. So what that gives us, right? We've got A, so it's primed here, so that means we're not going to prime it. B prime, and remember we've got ands here. Ands change to ORs, so there's our OR. And ORs change to ands. And we've got A not or B. And we also have to be careful and maintain our precedence order, right? So if we're maintaining our precedence order, this and this and happened before this OR. In this final state, as it is right now, B not ANDed with A not would happen first. So that means we need to put some parentheses around here. And we're done, right? This is our output. Be careful not to accidentally apply De Morgan's equivalent, right? We don't need to put this whole thing in parentheses and not it again. We're just distributing this complement or taking the De Morgan's complement. So let's look and see what we've got here. We've got a sum multiplied or ANDed with another sum. So this is a product. Oops, sorry, this should be, man, I screwed that up. This should be sum of, nope, product of sums. That's right, product of sums. We've got some sums here that are multiplied together. So sums and then their product. So this is actually kind of the long way to do it. There's also a shorthand way, there's a shorter way to do this. We don't have to apply the De Morgan's complement. What we can instead do is find our zero conditions, and then we can write out our terms. We can have A, B, we OR them together, right? So each individual term is ORed together, and we need to invert our 1 inputs. So any of the inputs that are 1s, we need to invert there. So we invert this one, and then we put parentheses around it. And we know that we're going to AND everything together. And so here we've got A is a 1, so that means we prime our 1 inputs is the exact opposite of what we would do for the sum of products. And we're ORing all of our terms together. And then we have B not prime because it's a 0. So it's the exact opposite. And then we just... So this is kind of usually the way that you would go, is you would just go directly this way. You wouldn't apply it to Morgan's complement, but it's just, this is kind of a way to consider it or know how to explain it to yourself.